Hello and welcome to... Today, we will be learning about carbon dioxide, bipolar characteristics, and also we will be learning a little bit about ammonium dichromate. But that's something you cannot do at home. The other two experiments you'll be able to do anywhere you possibly think you can.
On today's dancing raisins, you will need a glass, a clear glass, some Canada Dry, and of course some raisins. What you'll probably want to do is pour the raisins into a clear glass bottle, or just anything to hold it, just to keep a clear mess, let's just say that. Next, what you'll need to do is you'll grab your soda of choice. It has to be clear. Make sure it's sort of clear. And you'll pour it into your glass, obviously. As you'll notice, in the soda, there are tiny bubbles bubbling up to the top. What we'll do is we'll find this out later as to why this is happening. But remember this later for the video. Next, you'll grab at least a handful of raisins that you pour into a glass and you'll start dropping them in there. And now here comes the fun part. See the raisins going to the top? Now, why is this happening? Remember those bubbles we talked about earlier? Well, this is because the raisins have a rough surface that makes the bubbles want to stick to them. So, for the more scientific approach, there are tons of carbon dioxide bubbles in any of your sodas, just like the one seen here. What the carbon dioxide bubbles are doing right now is they are attracted to any rough surface they can attach to, just like the raisins. Once they grab onto the rough surface, all of them float the raisins straight to the top. However, when they are exposed to the air, they end up falling right back down again. It's fascinating, isn't it? So the next time you find some raisins and some clear soda, remember what you can do at home anytime you want. Now for our next project, you'll be needing some soap, some dye, and of course, you'll be needing milk. But do not forget a type of glass, and also you might want to do this project in a kitchen or even have some paper towels. Next, you're going to add the dyes into the center of your milk and make sure they are all in a circle of a glob. Finally, you're going to find a Q-tip or even a toothpick and add some soap on top of it. But be very careful, this is type of tricky. What just happened? As you can see, the soap, when it was added into the milk, the dyes decided to disperse from its glob. So what exactly did happen? Inside the milk you are using, there are tons of fats and also there are proteins within it. Yet, what does the magic in this project? It's the soap, of course, because the soap has bipolar characteristics which decides to break the bonds between the milk and also the dyes of your choice. So, chemistry? I think so. Now for our next project, you probably do not want to do this at home. Find a chemistry teacher that will do this with you. Also, don't forget your safety goggles. Thanks, Chase. Also, you might want to wear some gloves if you are doing this. What we are going to be working with this project is called ammonium dichromate. To get a more understandable approach about it, we're going to write down the formula first. Why we add a triangle over top of the arrow is to show there is heat being conducted during the experiment. Let's get this project started. First, you're going to have your teacher light the stick on fire, and remember, try not to burn yourself. As the experiment starts to burn a little bit more, you will notice there is more being conducted instead of less. Isn't that what fire is supposed to do? Well, let's check out the rest of the experiment. As ammonium dichromate burns, chromium oxide then forms, then nitrogen, and then a water gas forms as well. This is what we like to call decomposition. This is exactly what's happening during the video. As this project is done burning, you can take it out and observe its colors. As you can see, it's a darkish green.
Thank you for watching this week's video. I hope you enjoyed it and also learned a little bit about chemistry. So join us next week for some more chemistry fun.